Okay, so I just decided to go ahead and record this lesson of composition of two reflections, again, over intersecting lines. If you were going to reflect A over line M and then over line P, the result of going over one line, then another line that's intersecting the first line results in a rotation. The magnitude and distance the figure rotates is twice the angle between the intersecting lines. So in this example, you see how this is 60 degrees? They didn't write it here. It's still 60 degrees. Okay, one rotation, and then they reflected, and then they reflected K over line P. K A prime over over line P is A double prime. Notice that it starts off with A. This is your prime notation for the first reflection. The second one, they reflect A prime, and it's A double prime. So you just keep on increasing your tick marks if you're doing multiple transformations. That's called prime notation. So what happened is the angle that went actually from A all the way to A prime is not 60 degrees. This is 60 degrees. It's going to be 2 times 60 degrees, which is 120 degrees. Okay, so that's the actual full rotation over two lines, two intersecting lines. Now, if the lines were parallel, it's a different story. So we'll look at that in a few minutes. So what's going to happen? Oh, this is just a little bit cut off. You can see it on your in your ISN. By the theorem 9.3, the composition of two reflections in intersecting lines M and P, this is all we just wrote down, was that is equivalent to 2 times 60 or 120 degrees in a counterclockwise rotation about the point where the lines intersect. Okay, so now this, if I was going to describe what's going to happen if triangle F was reflected over line U and then line V, it would result in a rotation of magnitude. Magnitude is the size of a rotation's angle measure. So the magnitude would be 2 times 25, which is 50 degrees. This last example here has nothing to do with that really. It's just going to asking us to do a rotation of a triangle LMN with vertices -1, 1. So we're going to plot -1, -1. Plot it in the right place. Label it L. M 0, -4. That's on the y-axis. Careful plotting. And N -6, -2. I keep thinking that -5 is a -6. It's not. Go all the way to the end. That's where -6 is. And then down 2. And there's your N. Okay, so I'm going to connect the points now. If you want, use your straight edge. If not, just sketch it. And then we would look up the rule for rotating 270 about the origin. Okay, the rule on your paper for 270-degree rotation says you take your points X, Y, and what they become, and this is how the rule is written. We'll go back and look where it is in your ISN quick. It's right here. Rotation to 270 changes the sign of X and switches X and Y. Okay, so I'm going to jot that down. Y will be first, and the opposite of X will come second in the points. Okay, so the new points, L prime. If you change the sign of X and switch it with the Y, changing the sign of -1 would be +1. Switch it with -1, so -1, 1 would be L prime. I'm going to continue just writing the points down. Now, you can't change the sign of 0. Okay, it doesn't have a sign. So you just switch those two, -4, 0. And then when you get to N, N prime is going to be change the sign of -6 to +6 and switch it with the -2. So it's going to be -2, 6. -1, 1, label L prime. -4, 0, label M prime. And -2, +6, way up here, N prime. And we'll draw the figure. And that's what it looks like to rotate 270 degrees about the origin. If you follow what I'm pointing at, I'm going to go from M all the way, see 90, 180, 270. Okay, next page, please. Or is yours on the next page? I believe it is. Yes. We are not going to do glide reflections this year. I eliminated this from 9.4. It's not on the chapter test, and it's not on the final exam. So if you can cross out this last little line in the box. You need to know what a reflection is like, where it flips. We call it a flip. A translation, which is we call a slide. And rotation, which we called a turn. Okay, so the composition of reflections, we did not talk about composition in parallel lines. We talked about this one over intersecting lines. So let's go over the composition of two reflections in parallel lines is the same as a translation, not a rotation. The distance the figure is translated is exactly twice the distance between the parallel lines. So it's not that much to remember if there's an angle between the intersecting lines, you double the angle to tell the magnitude of the double reflection. If you do double over parallel lines, then you just double the distance between here. So what they're saying is H is from here to here. And that when you go all the way from the blue one to the green one, the first triangle to the third triangle, this distance is twice H. Whatever this distance was, you double it to get the how far it went in all. Okay? The composition of two reflections in intersecting lines is the same as a rotation. And the angle of rotation is exactly twice the angle between the intersecting lines. So all you have to remember is to double the number. Okay, so what this illustrates here is if you reflect the triangle over the first line and then the second line, your total transformation, or which is a rotation, is 2 times the angle between the lines. There's an arrow right here for this one. I could do it for every corner, actually. They're all rotated the same amount. Okay, that's it for the ISN. So now we're going to go to the 9.4 packet. I removed I didn't put these on your paper this time, but these are all the Common Core, or the things that we're talking about, the standards. When two transformations are applied to a figure, one after the other, the total transformation is a composition of transformations. It could be 2 or more. So compositions, like putting together 2 things, you might want to look at what happened in the end. A composition of isometries is another isometry. A better term for this in the Common Core standards is rigid motion. What that means is it stays the same size. It's on your 9.4 packet that you grabbed when you walked in. The first page. Do you find it? We got this now? I just wrote stays the same size because I think sometimes these words, we just want to remember what they mean. Rigid motion. Rigid means stays the same. Okay. So it's a movement that doesn't change size. Okay. We've got a triangle ABC with vertices 3, 3, 4, -2, and -1, -3. we're going to plot that on the graph. I've got to slide this down. And then we're going to do a double. We're going to do 2 steps. We're going to translate along the vector -5, 0, which means left 5, and then nothing else. You don't do anything for the up or down. Okay? That's all that's going to mean. And then the second is a reflection in the x-axis. And what that does is, this is the rule, it changes the sign of the y values. Okay, so that's what this rule is saying. And this one is saying subtract 5 from all of your points. So what they did was they subtracted 5 and added 0. Subtracted 5, added 0. Subtracted 5, add 0. That's how you get your first set of points. Now first, let's get the original figure plotted. So I'm going to slide down so you guys can see. I'm going to plot 3, 3, and label it A. 4, -2, write 4 down 2, that's B. C at -1, -3. Now these triangles are going to end up overlapping one another. So if you have color, it's helpful. If you don't, it's okay. Just don't write things too lightly, else you'll have trouble seeing what you're doing. You could. Okay, so once you've got your triangle drawn, we'll talk about what we're going to do for the first translation. Second one's a reflection. Okay, so to get the new points, what they did was they did 3 minus 5 and got -2. 3 plus 0 was 3. That's moving the vector left 5. Okay, the left 5 vector and not up or down. It was -5, 0. So then they did 4 minus 5 and got -1. -2 plus 0 is -2. We got to fill in C prime. -1 minus 5, -6. -3 plus 0, -3. So these are the points I'm going to plot now for the first transformation. All right, now if you would rather just count left 5 for each of your points, that works as well. 1, 2, 3, 4, 5, and label it A prime. Notice that that is the location -2, 3, which is what our point says, so you can verify. Take B, left 1, 2, 3, 4, 5. It happens to land kind of close to the triangle there, and label it B prime. And then C, left 1, 2, 3, 4, 5, C prime. And then draw the triangle. Okay, I'm going to do the next one in a different color. Because now we're going to take this one, the one with the prime notation, and we're going to do the next step, which is to reflect in the x-axis, which changes the sign of the y values. So you change the y to -3, and that becomes the A double prime -2, -3. For B double prime, it's going to be -1, +2. And for C prime was -6, -3, will become translated, reflected, will change the sign of the y. Do you need something? Okay. -6, +3. All right, so now we're going to plot those and draw the final triangle. So -2, -3. Oh boy, it lands right near where C was in the very beginning, but not really. It's 3 down from the x-axis because it's not C, it's A double prime. Okay. -1, 2, left 1, up 2. That's where B double prime is. And the reason is it was B prime is 2 below the x-axis, so you would go over 2 above. A prime was 3 above, now it's 3 below. And now C prime, it's 3 below, so you go 3 above. And there's where C double prime should be, and it says it's at negative 6, 3, and that is where I'm located. I'm going to grab my tool for drawing the segments and connect my points. Quite the busy picture. That's the final drawing. I'm just shading in while you guys are finishing drawing your triangle. Just because I can. Okay, now we're going to do number 1 as far as some more examples go. Triangle XYZ, vertices, let's start plotting. 6, 5, label it X. This is going to be a skinny triangle if I remember correctly. 7, negative 4, and 5, negative 5. See? Okay. Draw the triangle, which is quite a narrow one. Remember, we haven't talked about all the different types of triangles yet. We will learn them later. Okay, we're going to graph triangle XYZ and its image after the indicated. Now, I told you we're not going to have to know that it's called a glide reflection, but this is what one would look like, or it's an example of one. You don't have to worry about crossing that out or anything. It's not going to hurt us. We're just going to translate along the vector 0, 2, which will mean to go up 2. So you're not going anywhere to the right or left. You're just sliding up 2. So I'm going to go up 2. And just do it. I'm not even writing down all the new points. Take each of those up to and label them with the prime notation. Okay, and then draw over that triangle the new one. So again, you don't have to know that this is a glide reflection, but what a glide reflection does is it slides a figure and then reflects it over a line parallel to the original vector. So since this vector is up to, it has to do a reflection that direction. So we're supposed to go over the y-axis, and the y-axis is here. The easiest way to do this is to count how far the points are from the y-axis. So x, and we're reflecting not the original figure, but the x prime. So x prime is 1, 2, 3, 4, 5, 6 to the right of the y-axis. So I'm going to go 6 to the left. So it's going to be at negative 6, 7. And that's x double prime. I'm going to count how far z is from the y-axis. It's 1, 2, 3, 4, 5. So go 5 left. And that's z double prime. And y, I just did the wrong one. You see what I did? I did the original figure, didn't I? No. Supposed to do the red point, not the blue one. Okay, z is still, though, 5 away, so I just have to make sure it goes across the correct way. It's over here. Z double prime. And y double prime is going to be 7 to the set. Y prime is 7 to the right, go 7 to the left. And connect the dots. Make a triangle. And it should be flipped, and it is. It's flipped in a different direction, but it's reflected, mirror image over the y-axis. Okay, you guys got to turn the page. Did anybody still need that? It's going pretty slow, probably. Okay, we're going to... Oh, you guys don't have the points I found out written down, do you? Okay, so let's just write them down. And we're going to write everything that happens on this one in case so that when you have a question similar to it, you will know what to do. So 6, 5, y is at 7, negative 4, and z is at 5, negative 5. It's the same triangle that we plotted just a little bit ago. So we're going to replot the points and draw the triangle again. Okay, so I got my 3 points. Draw the triangle. Okay. Now it says to translate along the vector negative 3, 4. What that means is left 3, up 4 with each point, if you were going to physically do it. It also can be done this way, where you subtract 3, add 4, and do it to each point. Subtract 3, add 4, subtract 3, add 4. So let's write down the new locations. So x prime is going to be at 3, 9. Y prime will be at 4, 0. And z prime is going to be at 5 minus 3, 2, negative 5 plus 4, negative 1. Now, if you prefer to physically just go find x and then start moving it, left 1, 2, 3, up 1, 2, 3, 4, you should find yourself at 3, 9, just what we wrote down. Okay, and then label it x prime. Z left 3, up 1, 2, 3, 4. You're at 2, negative 1, which is where what our point says it should be. And 4, 0 is on the x-axis, and that's your y prime. Draw the triangle. And make sure everybody's got that drawn before we do the next step. Okay, the next step is to reflect in the x-axis. And that rule is you take your points and you change the sign of y. Okay, that's the rule that you could look up on your reference sheet for this chapter. So we're just going to write them down here. X double prime, you're changing the sign of y, so it'll be 3, negative 9. Y double prime, I can't change the sign of 0. And z double prime is going to be at 2, positive 1. So you can think, well, I know how to reflect over the x-axis. I just count how far the points are below, and I move them the opposite direction above. So if z prime is below, then you go above 1. That's why it's at 2, 1. Z double prime, it's going to land on top of each other. Y double prime is going to stay where it is because it's on the x-axis. And x double prime is going to come down from the x-axis 9 units. So it's going to be at 3, negative 9, which is what our point says. And then we have to draw that figure. And it's flipped over. Okay, now we're going back over composition of reflections. Everybody good? All right. We already discussed this, just another picture that we had already looked at in our ISN. So, the composition of two reflections in parallel lines is the same as a translation. The distance the figure is translated is, oh, didn't mean to get that lovely line on my paper, but I'll fix it, is exactly twice the distance between the parallel lines. I was trying to slide my screen a little wider and it wasn't happy with me. All right, so you need twice the distance between the parallel lines. You've got a nice picture of what's going on, and what it's saying is, if you know the distance from H between the lines, which is H units, once you do the translation, the distance from the one triangle to the other is twice that distance between the lines. And the other thing, composition of two reflections and intersecting lines is a rotation. The angle of rotation is exactly twice again the angle between the intersecting lines. So if this is x degrees, yep, the rotation from one point to the next corresponding point is twice the angle measured between the lines. Okay. I'm going to need to use a document camera to do the next one. Reflect over line A and then line B. So take the centimeter, millimeter side of your ruler. I'm going to take the distance P is from the line. Now we got to go directly over. So you just want to hold your ruler horizontally. And I'm counting 7 marks past 0, right? So just count 7 to the other side. 1, 2, 3, 4, 5, 6, 7. Make a dot, and we'll label that P prime. All right, so I'm going to go over and measure to this left-hand corner. And I've got 1.3. Okay, now this one's a little harder to count. I mean, that's 13 marks you'd have to count if you want to hold your ruler still. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Not sure I did that perfectly, but I'm going to... Should be 1.3 on the other side. Yeah, it's about there. Just make a little dot. The one that's on the line stays where it is. And let's just quick do a little estimate for this one. Okay, just to speed things up. I mean, you can measure that, but my goodness, it's 3 millimeters away. All right, let's measure this final one on the lower left. I have 1.1, which is 11 marks. Or I can just slide over here and then do 1.1 to the other side. Okay, now we're just sketching, guys. It doesn't have to be perfect. If you like to use your straight edge, that's fine. I'm just freehanding it. Okay, and we're only going to do 2 of these physically like this. The rest of them we can just talk about what's going to happen. Okay, now I got to go over line B with the one I just made. Okay, so I'm going to hold my ruler this direction, vertically. I'm going to take point P across the line. So I'm seeing that P is above the line about 1.7 or 17 marks. I think it would be easier if we did this. Slid straight down to the line and measured 1.7 to the other side. And that's going to be P double prime. Right, and then I'll just go and measure these little ones at the bottom that are about 4 millimeters. I'm just going to count 4 marks past the line. 1, 2, 3, 4. Do the same for the one on the right. Or not all the way to the right, but the one at the bottom, right? 4, 1, 2, 3, 4. Then I have one left. This is like the bottom of the figure, which is now at the top. And then line up straight with line B again. Measure to this last point here, which is a 1.2 or 1.1. Should be close to what this one was. Okay, I think I was a little bit off. So it's going to be, I'm going to slide it down here and just make sure I'm straight up and down, 1.1 or 2. And then I haven't moved this one yet. I guess I should have done that one, which is the same distance as this one was. So I'm just going to go right on my axis here and come down 1.1-ish, 1.2. All right, so draw the figure. Pretty good. But I know we're not going to come out perfect because these are just little millimeters, and this is a tiny little figure. But we got the idea. So it says to describe the single transformation. So you see the lines that we were crossing over were intersecting. It was line A and line B. 90 degrees between them. So what's the total distance this went? 2 times 90. So it's a rotation, 180. Okay, so that was going over intersecting lines with 2 reflections. And now we're going to do over parallel lines. What's nice, the first one, all we have to do is, and this P slid down to here. I don't know why it's really supposed to be up there. But we're going to get P to the other side of line A first. So we have only 1 point to do because the other 2 points are on the line. So from P to the line is 1.1 centimeters. So I'm just going to slide this down here, right straight down from there, and go 1.1. Label it P prime. And then I just need to connect to those on the base that are on the line we reflected over. All right, now we got to move all 3 points, though, to get the second reflection. So I'm going to measure bottom corner. Oh, let's get the distance between these lines. That's what we're going to get right now. How far is it from line A to line B? I've got 1.7 centimeters from here to here. Okay, so if that's 1.7 centimeters, I'm going to slide my ruler down to the second line and go 1.7 to the other side. Now it should make sense that this distance is twice 1.7. I'm going to get the one that was on line A on the right side, slide down from it, and go 1.7 to the other side. That's the bottom of the triangle. Then I got to measure how far P prime is away from line B. Are you guys getting about 0.6 or 0.5? 0.5 is good. Okay, go to the other side. Make your triangle. Okay, and that's P double prime. So what this was is a translation of the first figure to the third, the distance of which is twice the distance between the lines, so 2 times 1.7, which is 3.4 centimeters. All right, I hope yours looks pretty good. Get out of this thing. All right, so you have a small amount of homework after that. Very short assignment. Please work on that.